Somewhere at the edge of our solar system, a spacecraft launched before the internet existed is still sending home signals. Voyager 1, built with 1970s technology, has traveled over 23 billion kilometers. And right now, scientists are using something almost impossibly futuristic to decode what it's telling us. That something is quantum computing, and it's rewriting what we thought we knew about space. For decades, space exploration moved at the speed of human patience. Missions took years to plan, trajectories required months of calculation, and the sheer volume of data pouring in from satellites and probes overwhelmed even the most powerful classical computers. Every delay meant missed discoveries. Every inefficiency meant billions of dollars burned. The universe was talking. We just couldn't process it fast enough. That gap between what space sends us and what we can understand has always been the quiet crisis of astronomy. NASA's Quantum AI Lab began confronting this directly, applying quantum processors to problems that would take classical machines years to solve. The results were striking. Quantum computers can process complex space data up to 100 times faster than traditional systems. That's not an upgrade. That's a different category of tool entirely. Consider trajectory planning. Getting a spacecraft to Mars isn't like entering coordinates into a GPS. It involves thousands of variables, gravitational pulls, fuel loads, timing windows that open and close like heartbeats. Quantum computing can simulate all of these simultaneously, not sequentially. Studies suggest this approach could reduce mission fuel consumption by up to 30%. On a long-duration mission, that difference isn't just efficiency, it's survival. Then there's the question of communication. China launched a quantum communications satellite that uses quantum entanglement to secure data transmission across vast distances. Quantum key distribution, QKD, encodes messages in a way that makes interception physically detectable. Not just difficult to hack, physically impossible to hack without leaving a trace. For a world increasingly dependent on satellite infrastructure, that's not a technical footnote. That's a foundation. Black holes have always been where physics goes to break. Stephen Hawking proposed the information paradox, the idea that anything falling into a black hole is erased from existence, violating the fundamental laws of physics. For decades, it sat there, unresolved, like a crack in the ceiling nobody could reach. Then researchers began using quantum computers to simulate black hole mergers, modeling behaviors that no telescope could ever directly observe. The crack is still there, but now we have a ladder. Each of these breakthroughs shares something in common. They all depend on quantum computing's ability to hold multiple states simultaneously, a property called superposition. Where a classical computer sees a door as either open or closed, a quantum computer sees it as both until it needs to decide. Applied to datasets from space missions, this means patterns emerge that were always there, hidden inside the noise, waiting for a machine capable of listening properly. Here is the part that reframes everything. Quantum computing wasn't invented for space. It was developed to solve problems in chemistry, finance, and cryptography. Space agencies essentially borrowed a tool built for something else entirely, and discovered it fit the universe's problems better than anything designed specifically for them. The most powerful telescope we've ever built isn't pointed at the sky. It's running on a chip. We are living in the narrow window between two eras. Classical computing carried us to the moon, to Mars, to the edge of the solar system. Quantum computing may carry us beyond, not just physically, but in understanding. Every black hole we simulate, every trajectory we optimize, every secure signal we transmit, is a small act of reaching further than the generation before us could. That impulse, the need to know what's out there, is as human as anything we've ever done. What does it mean that our oldest spacecraft and our newest computers are working together to answer questions we haven't even thought to ask yet? Subscribe to factstormhub. We tell stories like this every day. Full article on factstormhub.com.